7.1 Parallel lines cut by a transversal. Symbols to use for congruent. If we're talking about congruent, we have an equal sign with a wavy line. And angle, the measure of an angle, is represented by this. Okay, so a transversal is a line that intersects two or more parallel lines. So if you have, let's say this is a parallel line and a line that intersects it, this is called the transversal. Corresponding angles. A pair of angles that lie on the same side of the transversal and on the same sides of the two lines. So if we're talking about corresponding, 1 corresponds with 5. So angle 1 and angle 5. They are corresponding. Okay, we could also have angle 3 and angle 7. We have angle 2 and angle 6. And lastly, angle 4 and angle 8. Corresponding angles are congruent. They're equal. So 1 equals 5, 3 equals 7, 2 equals 6, and 4 equals 8. Okay, another vocabulary word is alternate interior angles. Let's go ahead and write that these angles are congruent. Okay, alternate interior angles is a pair of non-adjacent angles that lie on opposite sides of a transversal and inside the other two lines. Okay, so example, we can have 3 and 6. They're alternate, so they're not on, they're on opposite sides, but they're both on the interior. So we have angle 3 and angle 6. We also have angle 4 and angle 5. They're on opposite sides of the transversal, but they're both inside the parallel lines. So we have angle 4 and angle 5. Alternate interior are also congruent. They are the same. 3 equals 6 and 4 equals 5. All right, let's go to the next vocabulary word. Alternate exterior angles. A pair of angles that lie on opposite sides of the transversal and outside the other two lines. So an example, 1 and 8. They are alternate sides or opposite sides of the transversal, but they're both on the exterior. So angle 1 and angle 8. They're both also congruent. So these are congruent. Okay, and then not only 1 and 8, but there is also 2 and 7. They're alternate, but they lie outside. So angle 2 and angle 7. Okay, same side interior. So it's a pair of angles that are on the same side of the transversal and inside the two lines. So an example would be angle 3 and 5. These are not congruent, but they are supplementary. Remember, supplementary is two or more angles that add up to 180. Okay, not only angle 3 and 5, but the other same side interior is angle 4 and angle 6. They are supplementary. They add up to 180. Okay, complementary angles is two angles whose measures add up to 90 degrees. Supplementary is two angles whose measure add up to 180 degrees. There are tons of examples of supplementary. We could say this is a straight line, so we could have angle 1 and angle 2. This is a straight line, so we could say angle 2 and angle 4. We could also do 7 and 8. Angle 7 and angle 8. And we could also do something that's not lying on the same thing. We could do 2 and 8. There are tons of supplementary. These are just a few examples. Vertical angles are opposite and congruent. So it's a pair of congruent angles on opposite sides of intersecting lines. Some examples are 1 and 4. Another one could be 6 and 7. Vertical angles are opposite and congruent. If this is 30, this is 30. Okay? If this is 150, this is 150. Vertical angles are opposite and congruent. All right. So it says find measure of angle 2 when angle 7 is 125. So if this is 125, angle 6 is 125. Therefore, angle 2, based upon corresponding angles, is also 125 degrees. And angle 3 is 125. Okay, this is based upon corresponding and vertical angles. Now, if we want to figure out the measure of the other angles, we can say 180 minus 125 will get me 5. So this is 55. Based upon vertical angles, this is 55. Based upon corresponding angles, this is 55, and this is 55. So you can know just one angle on a transversal and be able to figure out the rest. So we want to know, what is the measure of angle 2? It is 125, based upon vertical and corresponding angles. All right, so let's do the next one, B. If this is 3x, this is 3x. If this was 3x, this is 3x based upon corresponding, and this is 3x. If this is 6x, this is 6x. And if this is 6x, this is 6x. And if this is 6x, this is 6x. Okay, we want to know VWZ. So let's highlight VWZ. We want to know what this one is. Okay, well, based upon supplementary, 3x plus 6x equals 180. So that's combined like terms, we get 9x. We're going to divide both sides by 9. I get 20. But I don't want to know what x is, I want to know what 3x. So 3 times 20 is 60. All right. Okay, if this is 4x based upon vertical angles, this is 4x. Based upon corresponding, this is 4x. Based upon corresponding, this is 4x. Based upon vertical, this is 6x. Based upon corresponding, this is 6x. Based upon vertical, this is 6x. Okay, we want to know GDE. So, well, let's just do, okay, GDE is this first one right here. Let's highlight it. So we want to know what 4x is. What we can do is set up supplementary, and we can say 4x plus 6x equals 180. So 4x plus 6x is 10x. Then we're going to divide both sides by 10. And we get 18. Now, we don't want to know what x is, we want to know what 4x is. So 4x is 4 times 18. So 4 times 18. 4 times 18 is 72. Okay, then we have BEF. BEF is 6x. So with 6x, we have 6 times 18. So 6 times 18 is 108. All right, and then lastly, CDG. So we have CDG, which is a 6x, which is just 108.